Okay, let me talk about again 18 oxygen. 8 protons, 10 neutrons. So, yes, 5 minutes. Right. So now, as I was asking you, these are the neutron levels of 18 oxygen. Okay. So let me ask you, what do you think will change if we consider, instead of 18 oxygen, if we consider 28 oxygen? So 20 neutrons, 8 protons. Now you will say, sir, these levels will be filled up. That's okay. What I am asking you, very basic, what do you think will change overall here, the levels in itself? Now you first have to understand the very fact that when we were talking about 18 oxygen, we were near the N equal to Z line. That is, we were near the value of stability. We were in the value of stability. Okay. Now there, the potential that we use, the potential is such that these are the eigen values of the potential, right? Now, if I change a potential, say for example, I have a potential like this. So these are the eigenvalues. Suppose I change this potential and make it broader. What do you think the eigenvalues will be? They will just go down, isn't it? So here I am telling you that just by changing the shape of the potential, the eigenvalues are changing. Here also, look into the example. From 18 oxygen to 28 oxygen, when we are going, we are basically moving away far from the value of stability. And because of this change in neutron and proton numbers, basically isospin, the potential in itself will change. So the eigenvalues will change. Now, in this case, what will happen? Certain very interesting things will happen. Number one, the entire thing can shift. But I am talking about, I will subtract the core from the excited spectrum. So let me talk about the relative changes. There can be relative changes. One possibility is, it has been experimentally observed, is the existence of intruder orbit. What is that? It can happen that this 1p5 half can go between 1p half and 1p3 half. Or you can say, it has been observed that this also goes around. So this is what intruder orbit. This is one feature that is observed as we move away from the value of stability. Another feature is this thing. Even inside a shell, this is between cross shell, right? Shell 1, shell 2. This is between cross shell. This was cross shell phenomena. Now, even inside the shell, it is observed that, say for example here, the level ordering can change. Okay, the single particle levels can change. This is another feature which has been observed. So, if I have to do the configuration mixing shell model calculation for 28 oxygen, I have to first find out the relative spacing, the exact nature, position of the single particle orbits. Understand? Then after that I can do. So the simplicity that we have for the case of 18 oxygen will be lost, and here it will be much more difficult. But again, I will be able to do exactly the calculations only if I can have the results for 26, say 27 and near about. If I have the nearby spectrum, then I can get the information about the various single particle level orderings. And then I can proceed with the shell model configuration mixing calculation, and the procedure will be very much similar to that we have discussed for 18 oxygen. Okay, keep this in mind.